Good morning, student. Today we are going to learn time division multiplexing, in short TDM. After the completion of today's session, you are able to define TDM, explain the operation of TDM and classify TDM. So, first, what is multiplexing? Multiplexing is a technique in which multiple data signals can be transmitted over a single communication channel. In which multiplexing technique, data signals are transmitted over a single channel in different time slots is known as time division multiplexing. So, in case of time division multiplexing, the complete channel bandwidth is allotted to one user for a fixed time slot. One may need to differentiate between the various signals for proper data transmission. So in TDM, the complete signal gets transmitted by occupying different time slots. Okay? And the circuit that combines signal at the source end is known as multiplexer, and at the receiving end the circuit used to separate this signal is known as demultiplexer. So let's see this diagram. In this diagram, source ABC wants to transmit data through a common medium. Thus, the signal from the three sources is divided into multiple segments. The signal from source A divided into three segments like this: source B, source C, means one complete signal divided into three segments. So, by taking one segment from each source, the multiplexer form one frame. And always remember, each segment having a fixed time slot, because we divide the bandwidth as per time slot. So time slot is fixed for each source, and as per that time slot the signal is divided into multiple segments. So by taking one segment from each source, the multiplexer form one frame. So here three frames are formed, as three sources are present and each source having three segments. So here two frames are formed. As these segments are entirely different from each other, thus the chances of unnecessary signal mixing can be eliminated. When a frame gets transmitted over the particular time slot, the next frame uses the same channel to get transmitted, and the process is repeated until the completion of the transmission. So this is the basic principle of TDM. Here we have taken the example of three different sources, but one can perform multiplexing of n source signals. Both analog and digital signals can be multiplexed using TDM, means time division multiplexing, but its processing technique allows the multiplexing of digital signals. Next is the block diagram. This is a diagram of TDM system using pulse amplitude modulation technique. Here at the beginning, the system consists of multiple low pass filters. These low pass filters are basically anti-aliasing filters that eliminate the aliasing of the data input signal. What is aliasing? When someone violates the condition of sampling theorem, at that time aliasing occur, means the successive cycles are overlapped with each other. When we try to recover the original signal at the receiver section in this condition, we never get a proper signal. Okay, so this overlapping is aliasing, and here the low pass filter helps to avoid this aliasing. So it is known as anti-aliasing filters. The output of the low pass filter is then fed to the commutator. This one is the commutator. As per the rotation of the commutator, the samples of the data inputs are collected by it. Here, Fs is the rate of rotation of the commutator. As we know, Fs is the sampling frequency, and we have to keep the sampling frequency greater than equal to twice of Fm. So we set the value of Fs like that. Commutator perform the function of multiplexing. After that, modulation is done and signal is transmitted. Means here at this section modulation is done, and here we are using pulse amplitude modulation. After that, the signal is transmitted through the communication channel. At the receiving end, a decommutator is placed. This one is the decommutator. So at the receiving end, first the signal is demodulated. After that, it goes to this decommutator. So a decommutator is placed that is synchronized with the commutator at the transmitting end. The synchronization is required. This decommutator separates the time division multiplexed signal at the receiving end. The commutator and decommutator must have same rotational speed in order to get proper demultiplexed signal at the receiving end. After that, signals given to the low pass filter and original data is recovered at its outputs. So in TTM, we have to maintain the sampling frequency, that is Fs greater than equal to 2Fm. We know that. Thus, the time duration in between successive samples is given as Ts. If we have the sampling frequency or sampling rate, then we can get the time in duration, that is Ts equal to 1 by Fs. Okay. We have considered that one can use this for n input channels. Then one sample is collected from each of the n signals. Each frame will provide us with n samples, and the spacing between the two is given as, means if we have n number of samples, then Ts by n. This one is the time duration and this one is the number of samples. Okay. Pulse frequency means the number of pulses per second is also known as signaling rate, denoted as R. So the signaling rate R equal to 1 by spacing between two samples, means that is Ts by N. So R equal to N by Ts. Okay. We can also write it like R equal to N by 1 by Fs, means Ts equal to 1 by Fs, we know that. So at the end we conclude that R equal to N Fs. So the technique of time division multiplexing can be implemented like this. Types of TDM. The technique of time division multiplexing can be implemented in basically two ways, that is synchronous TDM and asynchronous TDM. So first one is synchronous TDM. In this technique, the time slots are assigned at the beginning. This leads to the wastage of the channel capacity, as in the absence of any data unit, that particular time slot gets entirely wasted. So see here in this diagram, here you can see that three sources are using the channel. So first source send A1 segment and third source send C1 segment, but the second source have no information for this time slot. So that source send a blank segment, or the time slot is wasted. Like this, in the second frame, the first segment is blank, means the first time slot is blank, as there is no information present with the source 1. Like this, number of time slots are wasted in synchronous TDM method. Okay. Next is the asynchronous TDM. It eliminates the drawback of wastage of time slot present in synchronous TDM. Here, a particular frame is transmitted by the transmitting end only when it gets completely filled by the data units. It exhibits higher efficiency than that of synchronous TDM. It dynamically allocates time slots as per demand. Means here this one is the frame 1. Frame 1 consists of two time slots. So here source 1 and source 3, means if source A and source C send their first segment, then in frame 2 source B and source C send their segment. There is no segment from source A. From this diagram we can observe that it allocates the time slot as per demand by the source. So this one is the efficient method. So TDM mainly used in a digital communication system, that is in cellular radio and in satellite communication system. So this is all about time division multiplexing. Thank you.